Hello everyone, this is solutions to this year's test 2, question 3a, which gives you this reaction here and asks you to find delta H using all of the different equations that are found underneath. So hopefully you have this in front of you to look at. This really does become a bit of a puzzle in this case here. You have to figure out which reactions you end up having to use. So the best way to do this, since we have a lot here to choose from, look at all of the individual reactants and products that you can find and see where you find them down in these equations here. And just go ahead and circle them, might be the best thing to do. So for example, the CS2 will show up in equation 4 only. So right off the bat, you know you're going to have to use equation 4. So let's just put that up there now, I guess. So equation 4 has CS2, 3O2 going to CO2 plus 2 SO2. Now another one we can look for, you see Cl2 shows up in a couple of different places. It shows up in equation 2 and it shows up again later in the bottom equation. So let's just kind of leave that one for now. But then look at the final one, the S2Cl2. So that one there shows up pretty much only in the second equation. So if we write down the second equation, and we see in the second equation it's a reactant, but we want it to be a product, what we have right there. So let's flip it instead. So this was equation 4. We want to do minus 2 for this next one, which is going to be 2S plus Cl2 going to S2 Cl2. And we can write the values down over here as well if you want. We have minus 1070. When we do the negative of this one here, we have to flip the sign. So we end up with minus 58.2. Now the other one, carbon tetrachloride. Where does that one show up? Again, in a couple of different places. So you can see in equations 6 and 7 is where that's showing up. You can look at those equations though and just kind of see. So the final one is much easier, not easier, a lot less reactants and products in it than number 6. So number 6 is a lot more going on in it, a lot more compounds that we haven't actually seen yet, even in the ones that we've written down up here. So a good bet would be to use equation 7 on there. And we can use it as is because we want 1 mole of CCl4 to be produced. So we have C plus 2Cl2 going to CCl4, and that value is minus 135.4. Let me show you can see that point. Now let's just take a gander at what we have right now. We have our CS2, we have our S2Cl2, and we have our CCl4. If you also look closely, we have 3 Cl2s as well. Some of the extra things that we have ended up in here with, we have some sulfur, some carbon, some oxygen, CO2, and SO2. Okay, so from now, you have to go and find reactions that are going to cancel out those species. So if you look through it there's a couple that just have those species in there. So for example, equation 3 has sulfur, oxygen, and SO2 all in the order of the placements that we'd want to have them in. So let's use that one to get rid of the SO2, the sulfur, and some of the oxygen. And you're going to want to have that one backwards because we want to have the SO2 on this side, and we want to have 2 of the SO2s on this side. So we're also going to have to multiply it by 2. Just to go back and fill in here, this is equation 7. So now we're going to use equation 3. We're going to go minus 3, and we're multiplying it by 2. So we have 2SO2 going to 2S plus 2O2. And so now you're at 593.6 for your value there. Now we have to get rid of, if you look here, you've gotten rid of your S's, you've gotten rid of your SO2, and you've gotten rid of some of your oxygen as well. You're still gonna have 1 oxygen left here, you have a carbon, and you have some CO2. So there happens to be, nice equation in there, equation number 5 also has carbon, oxygen, and CO2 in it. So notice it's in the opposite direction of what we're going to want. So you're going to have to reverse the order for that one. So negative of equation number 5, you have your CO2 going to C plus O2. And all you're going to have to do is flip the sign for this one. Okay. So hopefully we're at the stage now where we can go through, cancel out everything besides what we want. You should end up with the proper reaction in the end. And your delta H, after adding everything up, 3 minus 283.5 kilojoules.